Hello guys, so this is my fourth lecture in a natural language processing series, and today I'm going to discuss about challenges and opportunities in natural language processing. As I already mentioned you, my slides are taken from different sources on internet. Okay. So what are the challenges we are having? The first challenge we are having is the contextual word. We are saying the same word in different contexts. This will give me different meanings. We are using different phrases in natural language processing. Then I already discussed the homonyms. Homonyms can be spelled. They are different words, but they are having same spellings, or their phonemes are same. While speaking the word, you are having the same pronunciation. Or we can have irony and sarcasm. In case of irony and sarcasm, we say the reverse thing, what we are mean to. Then we are having ambiguity, we already discussed, but I'll give you some hard example of ambiguity today. Then next we can have errors in typing or speaking. Then people use slang words. Then the domain specific language and the low resource language. So let's come to the slide. First thing, what we want is the contextual words. So the contextual word, these are the same words used in different contexts, gives you the different meaning. So like in the first sentence, you see, I ran to the store because we ran out of milk. So this ran is for the shortage. What we are having, it is shortage. We are having a shortage of milk, and this ran we are using for the running. I was running to the store because we are having shortage of milk. Then can I run something past you really real quick? So can I run this run now? Again, run is a present tense of this run, and this run is you want to go in the memory. You want to go in the memory. So while going for the memory, again you are using the same word, that is run. The house is looking really run down. Run down, old. Now you are using this run for the old. The house became old. So that's why it runs down. So the same word in different contexts will give me the different meaning. And we say the homosemes. Homosemes, though this ran and this ran is a different word, but their spellings are same. In different contexts, they are giving me the different meaning, but their spellings are same. So again, we can have the pronunciation as same as well. So this is what about my context word. Then we have next is the irony or sarcasm. Irony or sarcasm is the same thing. It's not a part of speech, it's a figure of speech. We say it's a figure of speech. Um, as we are using the words, they are giving me the opposite. Like we are giving some comment to someone. So this is in a humorous language manner. We are going to scold somebody. So like I'm saying, your hands are as clean as mud. I want to say your hands are dirty basically, but I'm saying rather than saying dirty, I'm writing clean. The opposite word I'm writing here. The dinner you serve is as hot as ice. So basically, I want to say the dinner is it's cold. It's not hot. So rather than using not hot, I'm saying it is as hot as eyes. So such kind of things I want to build an NLP tool so that it can understand such kind of figure of speech. Then if I ask to Google Translator, I want a cool vegetable. I want a cool vegetable is I want something very interesting. I'm looking for something as a vegetable. Today my mood, I'm very happy. So I want a cool vegetable. So Google is giving me the translation is like मुझे ठंडी सब्जी चाहिए. So I don't want ठंडी सब्जी. I want something something that tastes spicy or something that seems to me awesome. So these are the example for sarcasm. Then coming to the ambiguity. Although we have already discussed about the ambiguity that but I just want to give you some example how ambiguity can be, how hard it is. So like I have a sentence. If I speak this sentence, will. So in a spoken language, I'm repeating the same word many times. But wherever I'm having this capital W, this means this is a person name. I'm talking about a person name. So wherever I'm having capital W, this is a person name. I'm talking about some person. And this statement is about three person. This is my first person, this is my second person, and this is my third person who's saying about the second person. This is a second person. So will means this is in future tense. This will is for the this is a verb for future tense. This is a helping verb for the future tense. And then second time I'm having will. This means I want this is an action what we want to do for the third person. So this person is thinking about the second person. So what we have is the first will is for a person uh, that will do something in future. Then about the second person, then second person is thinking about the third person. What third person will do. The second person is thinking about what third person will do, will write in his document. So this is the level of ambiguity we can have. In this sentence, we have the lexical ambiguity, we have the syntax ambiguity, and there are different kind of ambiguities present in this particular sentence. Then we can have another sentence that is having buffalo, 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 and buffalo goes many times. So the again the capital ones, the capital buffaloes, whatever is written in caps, first letter starting in caps, this represent the city name. This represents the city name. And I can have the animal buffalo. So this the buffalo used here in three different types. One is the city name, another one is the animal name, and third one is the buffalo that means outwit, confuse, deceive, uh, imitate, or the buffalo. So this sentence is structurally correct. If we say with the syntax, so this gives me a correct sentence because I can construct a past tree corresponding to this. This has a noun phrase and the verb phrase. Then the noun phrase is divided into the noun phrase and the relative clause. This relative clause is having the noun phrase and the verb phrase. And then we are having proper noun and the noun. So this gives me a correct past tree. Once I'm able to construct a correct past tree, my sentence is correct. Now, I want the meaning of the sentence. So, how to get the meaning of sentence? Well, I need to do the POS tagging. This is the example of POS tagging. So, first, whatever the words written in the caps, I'm saying they are starting from caps, from the capital letter, they mean to me a city name. That is the city name is the noun adjective. So whatever I'm having as the capital letter, these are the city names. This one is again my city name. Then next we are having buffalo is the animal. This buffalo as noun, this is an animal. As noun, this is an animal. Then we are having buffalo is written as verb as well. That verb is for the it is creating confusion. This is for the confusion or deceit. So I can draw by knowing the POS tags, by knowing the part of speech tags, I can give a meaning of this particular sentence. So these are the hard example of my ambiguity. Then, what makes NLP hard again is the ambiguity. It may be a lexical ambiguity. In the first two examples, we have seen the lexical and the syntax ambiguity. The structure of sentence. So, this kind of example we discussed in last lecture as well. I saw the man saw the boy with binoculars. So, the man may be uh, watching a boy with binoculars, or the man is holding binoculars and seeing a boy. This can have two different meanings. Then I can have flying planes can be dangerous. So it is possible that you are traveling in a plane and you're finding it dangerous, or it's possible that you're seeing a flying plane that is dangerous. Then another kind of sentence we used to make in our daily life, hole found in the room wall. So first we are writing the objective part, then we are writing the noun phrase. Police are looking into it. So rather than framing a proper sentence, first we'll be writing the objective, then we'll be writing the subject clause. So this again gives me confusion. Then your language can be imprecise. Imprecise is like many times we are using it is warm here. So it is warm here, there's no context available. This can be related to your AC is not working. This can be the weather is too hot today. Or this can be a place where you're living a place where it is always warm. Or like somebody asks you a question, did your mother call your aunt last night? So you are not sure about it, but you're saying, I'm sure she must have. You have a trust on your mother, and because of your trust, you are saying, even I don't know, but um, she must called. So this kind of language is difficult to understand by machine. It, as a human, for us, it is easier. So we need to build an NLP tool, a proper NLP tool that can recognize all this kind of ambiguity. Then there is some fun fact I tried for your lecture yesterday. So I given to Google. This is the examples of Google Translator. I written I ate chapati. So because in Indian dialect we won't say it is bread. We used to say chapati or roti. So for roti it is giving me the correct answer. For chapati, when I'm writing chapati as like this spelling, then it is giving me the correct answer. And when I'm writing chapati as this one, it is giving me a wrong answer. And even if you see the language got converted automatically. It is not taking, the Google is not taking my sentence as English language. It is converting the language and it's giving me the wrong answer. Then again, if I am asking something sarcastic, like if I'm asking Google is cool, it is giving me Google must have, that's okay. Or Google is awesome, then it is saying Google must have. But if I change my sentence, I change the order. I say the coolness in Google. So it is giving me Google में ठंडक, which is not true actually. Or I have given a sentence, I ate my tub in bathroom. So this tub may stands for the tub available in bathroom that we can't eat, but it may stands for a tub filled of popcorns. So if I'm having popcorn, I'm having a tub of popcorn, I can eat in bathroom. That's possible. So the machine should understand all these difficulties, the spelling errors. This one is, I would say, it's a spelling error. Or if I change the order of my word, so rather than I am saying Google is cool, I'm saying coolness in Google, then my computer should understand the what I mean to. Or if I am saying, if I'm using a word that this is a homosims, I can say it's a homosim. This tub can stand to a tub which we are using in bathroom, and it may stand to a tub which is we are having a popcorn filled tub. Then another thing is we are not writing the proper words in day-to-day language. Whenever we are writing something in social media, then how we write is word so proud. I want to emphasis on proud. So I'm writing so rather than so. Or you are writing you. Or you are writing some numeral instead of that English word. So, or in daily life, what we are saying, see you, or I will see you later. So later I'm saying LTR, see you I'm saying. So like our parents are surprised what happened to this young generation, what they are saying. Or we are lazy in writing, so we are writing something. So for all this, we need to make a dictionary. That's what we are saying. The natural language is having a low resource language, and low resource is because these words are not standard. We are capable of handling the standard words, but we are not capable of handling the words which are not available in dictionary. So we need to prepare dictionary corresponding to the words what we are using in daily life, or we are writing different spellings corresponding to different words. So this is another challenge in NLP. We need to handle such kind of language. Then one application we are having for NLP is information extraction. So this is a paragraph. This is one paragraph taken from a news article. So this is a newspaper, New York Times. New York Times given a name. There is a name which is available two times. One time is as an referential word. He is the pronoun that is used for this particular person. So I'm having this person two times. First time, this person appears as a president and or the general manager. This person appears as a president and the general manager. Next time, this person appears as the executive vice president and deputy general manager. So there are two roles this person, the same person is playing. And first time this has come as president and general manager. Second time it has come as executive vice president. Then we have another name present. So this is my information extraction is I want to extract all the names and what all in which company they are working as and what all their post and whether they are coming in beginning or end. So start means when first time this name appears, then so this person, the second person, we are having second name is this one, and this person is working in again in the same company, that is which company? This is New York Times. New York Times and working as a president and CEO. And this is at the first appearance of this particular name. So how this kind of information extraction is possible? For this, we need to prepare knowledge graphs. Knowledge graphs are the graphical representation of your knowledge or information. So what information is, what we are having is, we are writing Da Vinci is a person who painted a painting with the name this, and this person is located in, this is an instance of a person. Then some user, Lily, she's interested in paintings made by La Vinci. So I can have a connection between Lily and Mona Lisa through Da Vinci. Similarly, there's another function a person who is friend of Lily. So if this person is a friend of Lily, their interest may be same. So they may be liking the same painting, or this person, James, he visited to different countries. So Lily may be interested in visiting the same countries. So this kind of information we can infer by the knowledge graphs, or informations we can extract from the knowledge graph. After this knowledge graph, next thing we are having is what is going on in NLP right now. In past, we completed this information retrieval. We made the knowledge graphs. We are having WordNet available to us. Then we are capable of doing the machine translation in many language. We are able to do the language translation. At present, we are doing the sentiment analysis, and in future, we want to do the information extraction. Using this knowledge graph, now we want to extract the information in future. We want to build a question answering system, which mostly we did with the ChatGPT, but still ChatGPT is giving me some wrong answers. Sometimes ChatGPT fails. So for that, we can make a question answering system. And for different domain, we require different kind of chatbots that can be developed in future. Then how the words are represented in, as I told you, there is a word net present, word sense net. So in different sense of a word, it is represented with a vector. So like male, men and women is related to each other. So we'll make a vector in my three-dimensional space. So this three-dimensional space is according to the different quality of woman. Then the king is related to queen. Then we say the walking is related to walk, or intimate is related to um, this is intimate. This intimate is related to sorry, this is not intimate. So I'm not able to read it. Sorry. This is a relationship between this is the relationship between the country and the capitals. the capital of the country is connected to each other. So in this word sense net, we have made all this relationship. Sorry, not we, the Princeton University, the inventor of the word sense net, they made this relationship, this all relationship is already built in the word sense net. Then, as I already discussed, the natural language processing is having two modules. One is the natural language understanding. When human gives some task to the machine will understand what human wants to say, and then machine used to answer corresponding to what the machine wants to reply. So that is my natural language generation. Now we are having three different related terminology. That is, one is the natural language understanding, natural language generation, and so natural language processing and the automatic speech recognition. We can have various automatic speech recognition software available with us. So how they are related to each other. In case of natural language processing, we do the POS tagging, we do the name entity recognition, we do the syntactic parsing, we do the text categorization, the conference resolution, we do the machine translation. Whereas in case of natural language understanding, we paraphrase the sentences, we do the inferences, we do the semantic analysis, dialogue agent, we are building a dialogue agent, we do the summarization, the question answering, then the semantic parsing, and lastly, we do the relation extraction with the natural language understanding, whereas your automatic speech recognition come outside the natural language processing and the natural language understanding, in which we generate the speech from the text. Automatic speech recognition will we are taking speech signals and we are converting to the written sentences, and then the written sentences to be converted to the spoken sentences. So this diagram is giving you a relationship between natural language understanding, processing, and the automatic speech recognition system. Um, the machine learning plays an important role in case of natural language processing. So what I told you, the first we have the natural language understanding, then it goes to the machine learning model, and then from the machine learning model, then it generates the uh, final answer that is to be answered by the machine. So this whole is the process of machine learning. Then again, we are having many conventional AI systems, like you are having Google Commenta, Copilot, then language generating tools, many tools available. And another we are having is the chatbots. So what chatbot does is chatbot understand our sentences and they produce a response. Whereas the conversational AI, they understand the sentences, they also understand the sentences as well as the voice command. They can take input as voice command. So Alexa is the example of your conversational AI, whereas the chatbot we are having the ChatGPT is the chatbot, or we can have several chatbots available. So, sorry, this is ChatGPT. ChatGPT, we can so it's an example of chatbot. The conversational AI working on different channels, whereas the chatbot does only the chatting. They are working on the single channel or single interface. The conversational AI optimize the natural language understanding unit, whereas there's no optimization. The chatbot works on the stream of the pre-trained model. Then uh, conversational AI designed for the dialogue, for different dialogue, whereas in chatbots, even right now, people are doing the programming for navigations. Then these we have the learning capabilities in case of conversational AI, whereas in case of chatbot, what we have is there's something stored in dataset. So, oh, sorry, I can say this ChatGPT is not an example of chatbot. The standard chatbots we are using IRCTC website or some hospital system. So whatever the chatbots we are using nowadays, they are, uh, we can say, uh, there are statements stored in that in a database, and they used to patch the statement. So whenever we want to update it, we need to reconfigure with the new update. And once we reconfigure, like some product ads or some services I'm adding in my hospital, then I need to reconfigure my chatbot because we don't have learning capabilities, whereas the conversational AI is having learning capabilities. So that's all about today's lecture. If you like my lecture, and these all are the problems present in NLP, I can design different systems uh, with these topics. Mm, So this is all about today's lecture. Thank you very much. If you like my video, please hit the like button. And if you have any queries, you can write in the comment box. You can mail me, or you can talk to me on phone. Thank you very much. Have a nice day.